Hey, me again. Chapter 9 this time. Okay, I'm in an art museum today. I think this on the back here is called art. I think somebody threw up maybe, but I've called for somebody come clean it up. But I think it's art. You say some, I don't know. Anyhow, let's get going. We got more important things to talk about here. We're on chapter 9, toxicology. So that's in. Well, I gotta say everything is interesting in this book because this is all good stuff. And I'm not just saying that. It's true. Chapter 9, toxicology, how hazardous chemicals enter and affect the human body. Good to know. Chapter objectives, understand the different routes of entry for chemicals, define basic terminology for hazard exposures, describe how chemicals can affect the body, and determine ways to minimize the potential for exposure. All right. Now, again, these chapter objectives aren't going to all be in this little video. This is a short video. It's a short chapter, too. And so you need to read the book. Understand, okay, hazardous substances enter through the body through 4 major ways: inhalation, absorption, ingestion, or injection. And when it comes out of the body, it looks like this art behind me, I think. Inhalation, breathing vapors, smoke, fumes, gases, dust, mists, particulate matter, others. And most injuries are through inhalation. That's the route of entry most of the times for hazardous chemicals. Blood vessels in the lungs have a surface area of about 90 square yards. So this stuff is very rapidly absorbed into the bloodstream. Direct contact with skin or eyes is called absorption. Now, it's worse if your skin is damaged or cut, even if it's chafed or something like that. If it's just roughed up or damaged, the contact, generally speaking, your skin does a pretty good job keeping stuff out of your body. That's what it does, jobs. But if there's a break in your skin, it's going to get in pretty quick. And your eyes have many capillaries, so they're going to absorb airborne chemicals pretty quickly too. Ingestion is swallowing it. You're going to take a drink of some chemical? Probably not, but it might splash into somebody's mouth, or most commonly, you can get contaminated food or drink on a site. Puncture wounds is the injection is the 4th entry. Stepping on a nail or something sharp like that, attempting to blow chemicals off of the skin with high pressure air could shoot it into your skin instead of blowing it off. That's why you're only allowed 30 psi. Once chemicals enter the body, we need to be aware of how they can affect us. We need to look at the toxicity rates of certain chemicals to determine how hazardous they may be. Toxicity is the relative ability of a substance to do harm. Toxicology is the study of these agents and their effect on the human body. Ology, in any word, is generally the study of something. Dose influences whether the effects of exposure are toxic, non-toxic, or beneficial. And a good example is H2O, which is commonly called water. Duh, like you do that. Anyhow, can water hurt you? Yeah, you can drown in it. Can it be beneficial? Yeah, it is beneficial. You need to drink it. So it can be all things good or bad depending on the dose. Toxins produce their effects at low doses. So something called a toxin, that means it's going to be a very low dose for their effects to have an effect. Dose response terms include threshold limit value, permissible exposure limits, time weighted average, short-term exposure limits, STEL, ceiling, toxic dose low, which is TD at low, toxic concentration low, TC low, that's LO at the bottom, not 10. Dose response terms are also lethal dose low, LD low, lethal dose 50, LD 50, lethal concentration low, LC low, and lethal concentration 50, LC 50. So the most common one probably is LD 50, and that's when they take a chemical and they expose it to animals, frequently rabbits, and 50 of them die. It's a lethal dose 50. That sounds cool, but we got to figure out a way to protect humans. Types of chemical exposures, acute or chronic. And I don't know what this dude below the skull and crossbones there was taking, but I wouldn't advise it, taking it. What's the difference? Excuse me. Acute happens right away. In other words, you sniff it, plop, you're dead, or you're being affected by it. Chronic, you may not even realize you're doing it at the time or being exposed to it at the time, and the effects are over time. Chemical asphyxiants are gases that prevent the body tissues from getting enough oxygen. Carbon monoxide is one, and cyanide's another. Irritants are chemicals that irritate the air passages, causing constriction of the airways. Hydrogen peroxide, chlorine, hydrogen chloroxide, ammonia. Now, just because they're irritants doesn't mean that they're just going to irritate. They could kill you too. Necrosis producers. I worked around ammonia at OK Foods. I didn't work around ammonia, but it was there, and we dealt with it. I was process safety management. And the only incident I know of personally, and I didn't know this person, it was somebody get killed. There was an ammonia release somewhere, and it was on the news. It wasn't around here, and it was at a low storage facility, something like that. And there was such an ammonia cloud that went across a highway, and the police were there stopping people from going in there. Well, one lady decided to go around it and go into this ammonia cloud, died. So I don't know why you would do that. There's law enforcement or somebody like that telling you it's dangerous. Don't go there. Well, why would you go there? Well, Darwin's law. Necrosis producers, chemicals result in cell death and edema, ozone or nitrous oxide. Fibrosis producers, these are again inhaled toxicants. Chemicals that produce fibrotic tissue, which if massive, can block the airway and decrease lung capacity. Silicates, asbestos, beryllium. We've heard about asbestos. You can generally tell in an older building if there's asbestos in the tiles. If the tiles are 9-inch by 9-inch, the floor tiles, that's probably an old tile, and it's probably made of asbestos. And if you're going to take that out, you need to have special people do it. Many chemicals used or produced in industry can cause chronic or acute diseases. These respiratory toxins are classified according to how they affect the respiratory tract. Asphyxiants are gases that deprive the body tissues of oxygen: nitrogen, helium, methane, neon, and argon. Allergens are chemicals that induce an allergic response characterized by bronchial constriction and pulmonary disease. Isocyanates, sulfur dioxide. Carcinogens are chemicals that are associated with lung cancer. Well, carcinogens are not really. They're associated with cancer. Cigarette smoke, coke emissions, asbestos, and arsenic. Factors that influence toxicity of chemicals are, of course, the chemical itself, the routes of entry. The person's sex could influence it, their age, the genetics of the person. There may be some genetically more have a predisposition to certain diseases. The environment around them and the environment of the person could be a factor too. Combinations of chemicals can produce different effects from those individually. Some may enhance the effect while others may lessen it. Synergism are chemicals that, when combined, have a greater than additive effect. An example of that is hepatotoxicity is enhanced as a result of exposure to both ethanol and carbon tetrachloride. Potentiation is a type of synergism where the potentiator itself is not usually toxic by itself, but has the ability to increase the toxicity of other chemicals. Antagonists are chemicals that, when combined with other substances, lessen the predicted effect. So you can see by these three reasons right there, if you're going to mix any chemicals, it's not a good idea unless you absolutely know what you're doing. And if you're just going to randomly mix chemicals, you are asking for trouble. So this is a short video. This is your short chapter, and that's the end of it. Again, read the book. All everything's going to come out of the book. So that's it for this time.